This conference will now be recorded.
Okay, this is me, part 2 of the videos. We were in the middle of the related rate problems. So this is another Pythagorean theorem problem, essentially, because you have this right triangle here that's related to this. So we need to read the problem to see what each piece is. So it says a boat is being pulled by a winch on a dock. So notice this is pulling the boat up towards the dock. The dock is going to be a steady 12 feet. So that is an unchanging piece. But this is going to get pulled closer, and the boat is also going to be getting pulled closer. So the winch is 12 feet above the deck of the boat. The winch pulls the rope at a rate of 4 feet per second. So we do know our change in speed of how short this is getting. Find the speed of the boat when 13 feet of rope is out. Okay, so here's what we know. We can call this side A of the right triangle, because here's our right triangle. We have an unknown B and we know our C. So what we know so far is that A is 12 feet. B is 13 feet, or sorry, C. Can't erase with this guy very good. And then B we don't know. So we're gonna have to use Pythagorean theorem to figure out B. So remember A squared plus B squared equals C squared. So 12 squared plus B squared equals 13 squared. That is 144 plus B squared equals 169. You subtract and you get 25. So B squared equals 25, which means B equals 5. So we know our three sides of our triangle now. This is a very pretty much non-changing deck or pole. This 12 feet is not going to change. So that means dA dt is a fixed thing that never changes. So that means its change over time is 0. We do know that the rope is being pulled in at 4 feet per second. So dC dt is changing at 4. We don't know the speed of the boat, dB dt, because that's how close is it moving to the dock or how fast over time. So that's what we're looking for. So remember our formula is A squared plus B squared equals C squared. And we're taking the derivative of this with respect to time. So this would be 2A times dA dt. I have no idea why my PDFs are going nuts today. I'm so sorry, guys. 2B dB dt and 2C dC dt. Okay, so we plug in everything we know. So we know that A is 12. So 2 times 12. The change in the height of the, I guess this is the dock, essentially, is nothing. It's never going to change. And then we have 2, and B is 5. And we don't know dB dt. That's what we're searching for. And then we have 2 times C, which is 13, times 4. Okay, so 2 times 12 times 0 is nothing. So this is just down to these two pieces. So this is 10 dB dt equals, that would be 8 times 13. So let's see, 13 times 8 is 104. We would divide both sides by 10. And technically, we don't usually change these to decimals. We just leave it as a reduced fraction. So I know those are both divisible by 2. That makes 52 over 5. So 52 over 5, and this was feet per second, I believe, is the speed of the boat. Now, obviously, if you were wanting to know what that is as a decimal, you could get a rough estimate. It's 10.4 feet per second. Okay, and then that leads us to number 8. This one, the ones on the back side all usually have to do with money, and more of what most people would encounter in their everyday life. So it says a company is increasing the production of a product at a rate of 25 units per week. So the demand and cost functions for the product are given by the formula P equals 50 minus 0.01x, and C equals 4,000 plus 40x minus 0.02x squared, where x is the number of units produced per week. Find the rate of change of the profit with respect to time when the weekly sales are 800 units. Okay, so there's a couple things we have to realize about the way this problem has been given to us. First of all, they want the rate of change of profit. So profit is, remember, revenue minus cost. We don't know the revenue function yet, but they did give us the demand function. So if you remember from our previous units, revenue is always the x times the p, where this is the demand function. So number of units times that. So we need to figure out revenue first. So R equals x times 50 minus 0.01x. And we would distribute that. So that's R equals 50x minus 0.01x squared. So there's my revenue function. Okay, so that's one thing I needed. So now let's get our profit function because we want a rate of change of profit. So profit, remember, is revenue minus cost. And cost you want to put in a parentheses because you have to subtract the entire function, which means you have to distribute that negative. Excuse me. So if we distribute that, that's going to be 50x minus 0.01x squared minus 4,000 minus 40x. This is really getting worse. Sorry, guys. I don't know what's wrong with the pen. Plus 0.02x squared. Okay. Combining like terms and putting this in order from least to greatest, the 0.01 and that's negative and the 0.02 that's positive add together to make 0.01x squared that is positive. 50x minus 40x would be positive 0.10 or positive 10x, not point. And then we have minus 4,000. All right, so that was brutal, but we now have our profit function. Okay, so we want to know what else did they give us in this problem. They told us the change in the number of units, which is our x, over time, because it's per week, is 25. So, and it's increasing. That means it's a positive. If they said decreasing, we would need to think of this as a negative 25 when we plug it in. And then the number of units, they've told us x is 800. So if we want to find the rate of change of profit over time, we need to take d dt of everything. So that means the derivative of p is 1, but you have to tag on the chain rule of dp dt. The derivative of this would be 0.02x, and then we have to tag on our dx dt. And then derivative of 10x is 10, but because it's, again, not a t, we have to tack on the dx dt. 4,000's derivative is 0. So now all we're doing is we're going to plug in the x was 800 and the dx dt was 25. So 0.02 times 800, because that was x, dx dt is 25. And then plus 10 times dx dt, which is 25. Okay, so we're going to work this out. So 800 times 0.02 times 25, and then plus 10 times 25. So we're getting 650, and that, remember, is profit, so that's going to be dollars, and it's change over time, which our measurement of time was per week. So dollars per week. Okay, so that's that one. Let's look at number 9. It says a company that manufactures pet toys calculates that its cost and revenue functions are here, so they've given us both of them, where X is the number of toys produced in 1 week. During a particular week, there's 5,000 toys, so notice that's a singular unit of measure, so that's our X, and it's increasing at a rate of 250 toys per week. So that's our dx dt, and it is positive since they said increasing. To find the rate of change of cost, we need to do dc dt is essentially what we're solving for. So we're taking the derivative of this first function with respect to t. So for A, that would be derivative of 75,000 is 0. And then derivative of 1.05x is 1.05. Because it's not the t, though, we're going to get a dx dt. And my pen is still spinning, so I can't write yet. There we go. So A is, uh-oh, that's never good. Okay, so A is going to be dc dt, because derivative of c with respect to t would be 1 with a chain rule of dc dt. And we said it was 1.05 dx dt. So to find the answer to this first one, we just need the change in cost of the rate of that. We just need to plug in the 250 because the x didn't show up at all in this one. So we're just doing 105 times 250. Which is $262.50. So $262.50 per week. I may not be able to finish recording this video today, guys. I'm going to try, but I think my husband might have to fix my laptop. The rate of change of revenue, we're going to take the derivative of that R. So that would be dr dt, because derivative of R is 1 with the chain rule. But then we get 500x, so that's going to be 500 times dx dt. And then this one is negative 1 over 25. And then we have to pull that 2 to the front for that power rule. So that's going to end up being negative 2 over 25 for the coefficient, x to the first power, and then we have our chain rule of dx dt. So this one's a little more complicated to plug into. So we have 500 times the 250 for the dx dt minus 2 over 25 times 5,000, which is x toys, and then times the 250 for the dx dt. Okay, so I'm going to work out that second part first since it's a little nastier. So 5,000 times 2 divided by 25 times the 250. So I'm just multiplying those three pieces together, and then I need to make it negative. And then add that to the 500 times 250. Now this is going to be a lot because this is their revenue. So it's 125,000 minus 100,000. So that's 25,000 per week. That's how much revenue change they're seeing. So they've got low cost and they've got high revenue, which is always good for any business. The last question asks you to find dp/dt. Now here's the great thing about what we just did. You don't need to find the profit function here. You already know dr dt, you already know dc dt. So if you just take dr dt minus dc dt, that gives you the change in the profit because you've already done both of those derivatives and plug them in. So I'm not going to try to write out all the numbers, but we are going to do the subtraction. So 25,000 is the revenue minus 262.5, which is 24,737.50. So I think my pen is pretty much dead. $24737.50 per week. That is illegible. Okay, so I am going to have to stop here because this is becoming painstakingly slow to try to record this. I'm going to have my husband look at whatever's going on with my computer, and I will hopefully we only had one more, I believe, in this section, and then we had just a few in the 3.1 section that we had been working on. So look for a third video a little bit later, hopefully maybe tomorrow, and then we will be completely caught up on our videos.